All right, this time I'd like to show you in a screencast video how to use StatCrunch to find confidence intervals for population means using either the t-distribution when sigma is unknown or the z-distribution, normal distribution, when sigma is known, which is very rare. Sometimes, in fact, most of the time, we are given the sample statistic values for the sample mean and the sample standard deviation, but sometimes we are given data. I've already shown you how to use the Get More Help and pull up to open up StatCrunch. So now I'm going to maximize the StatCrunch menu. And in order to show you how I would use StatCrunch to find confidence intervals. For example, one based on the metal screw links that had an average of 4.8 centimeters with a standard deviation of 0.8. I would click on T-stats and go to one sample with the summary statistics, with summary, not with the data. And then click the radio button for a confidence interval. And we were asked to compute a 95% confidence interval where the sample mean was 4.8 centimeters. Sometimes I click two buttons and I get that error code. 4.8 centimeters with a standard deviation was 0.4 centimeters. And that came from a sample size of 30 screws that were measured, meaning a degrees of freedom of 29. You don't have to find all the critical t-values and find the error and atom subtracted to the sample mean. It will automatically do it for you and compute it. To the closest 100, that's 4.65. And that 9 would make the 4.949 round up to 4.95. So that totally aligns with what we got when we did this using other methods. For option number 7.2, from 7.2 worksheet, which was based on the sensory rates after patients underwent acupuncture, I don't know what the units for these rates were, but they were given in data. So they're in this first column, var1, and these are these values 8.6 through 6.9. I don't really know exactly what these measurements indicate, but obviously probably higher numbers are better sensory rates than lower numbers. And here, to compute the confidence interval, you would still click on the stat menu and go to T-stats and one sample, but you would do it with data this time. So now the data for this problem is in var1 column. So you'd select var1 as the column. You'd select the radio button for confidence intervals. And we were supposed to compute a 98% confidence interval here. So just change that to 98%. And it's as simple as clicking compute and bingo. The lower limit of 7.09 and upper limit of 9.36. Once that 9 rounded to 5 up to a 6, also align with the answers when we did this by hand and used both Microsoft Excel and the graphing calculator confidence interval app. So I'll close that. And the third example that was in the worksheet was based on the weights of females in hectograms, where apparently sigma is somehow known, even though we're creating a confidence interval for the population mean. So this is back to using sample statistics, but since sigma is known, it would use the z critical value. So you do have to know that since sigma is known, when you click stat, you're not going to do t-stats, you're going to use z-stats. And again, you click one sample, and we were provided with the sample statistics of the mean being 30.9. But since we use sigma, we use that instead of the sample standard deviation. We go to summary, and we put in the sample mean, which was 30.9 for this sample of, I believe it was a sample size, I'm not sure, but I think it was from 12 birth weights. Don't quote me on that, but you can look at the worksheet. So when you click the confidence level here, I believe it was a sample size of 12. Actually, it was 15. It was 15 birth weights, never mind. And so I'm going to put that in for the sample size, and we use the standard deviation from the population of 2.9. And so the confidence level was 90% for this confidence interval, and we compute it, and we get 29.7 after rounding that to the closest tenth due to that 6, meaning that 6 would round up to a 7, up to 32.1, which once again aligns with the values that we did in the worksheet. The you try it examples at the end that were blank that you were supposed to work on at the end of the worksheet started off with TV watching hours for students. So this is when sigma was unknown. So we're back to using the t-stat one sample with summary option. And the sample mean given was, actually, to be honest, this problem had data. So we would, I've put the data values here for the number of hours that students watch television on a weekly basis. And so those are number of hours of TV watching per week in column var2. So when I use stat, and apparently actually sigma is unknown for this problem, so we are going to use the t-distribution, one sample data option. So we select the data that's in var2, create a confidence interval by changing that radio button, and it was supposed to be a 95% confidence interval, so we don't even have to change that. When I push enter, you'll notice that this would be 3.08, and this would be 9.18 after rounding. And those are off a tad bit from what's on the worksheet, but that's due to rounding error, and this using a very accurate value for the mean and the standard deviation, which is a little different from what I did in Excel and when I did it by hand, but they're all definitely in the same neighborhood. The UTRITE number 2 problem was the hours of sleep after patients had hypnotherapy sessions, and sigma still was unknown. So we're going to use the t-distribution. So you click stat, t-stats one sample with summary, because we know both the sample mean and the sample standard deviation. And the confidence level for this confidence interval was 99%. And the sample mean was 8.98. And the standard deviation apparently from this data was 1.29. Apparently they slept on average almost 9 hours, 8.98 hours with a sample standard deviation of 1.29 hours after undergoing hypnotherapy. The sample size for this was 12, meaning the degrees of freedom is 11. So I've already explained how you would look up critical t-values and compute the error and add and subtract the sample mean, but this does it automatically, knowing that the t-distribution applies here. So I will push compute, and to the closest hundredth, that's 7.82, and this would be 10.14 due to that 6 rounded the 3 up to a 4. Once again, aligning with the answer in the worksheet. The third and final example from the worksheet where you were trying to do the problems on your own was where apparently we knew the sigma value of 2.9 hectograms was the population standard deviation for birth weights of females. So it's actually a repeat of the problem before based on birth weights, but it was a new sample, not of 15 babies' birth weights with a sample mean of 30.9, but 22 birth weights with a sample average of 31.1. So we go to, since sigma is known, we're going to use z-stats, not t-stats. We go to one sample with summary. We select the confidence interval option, and it was 95% confidence interval, so we don't have to change that. And the sample mean for this sample was 31.1 hectograms. We still use the population standard deviation of 2.9, but now the sample size comes from 22. It'll be used to compute the error, but we will use the z-critical value since sigma is apparently known. You simply click compute, and the lower limit of 29.9 after rounding, because that 8 would make that 8 round up to a 9, up to 32.3 would also align with the answer. We did it by hand and using other methods of technology. StatCrunch is pretty nifty and cool.